Hello students, you have learned relation and representation of relation in different forms in our previous video. In this video, we are discussing types of relations. There are various types of relations. Among those, today you will learn few important types. One-to-one, many-to-one, one-to-many, identity, inverse. Let's discuss it one by one. The first one-to-one relation. Let's explain it with an example. Here, A and B are two sets. A has its element 1, 2, 3 and B has its element 1, 4, 9. R is relation from set A to set B and its order pair are, its elements are 1, 1, 2, 4, 3, 9. Representing it in an arrow diagram, here set A, its elements 1, 2, 3 and set B elements 1, 4, 9. Now the relation is from set A to set B here, set A to set B, and representing these order pairs, elements of R with an arrow here. 1 is associated with 1 here, and 2 has its second component 4, 3 has its second component 9. Here 1 is associated to 1, 2 is associated to 4 and 3 is associated to 9 here. One element of A is associated with only one distinct element of B. That is, each element of A has only one distinct element in B. So arrow is here 1 to 1, 1 to 1. So this relation is called one-to-one relation. Let's define it. One-to-one relation. Let A and B be any two non-empty sets if different elements of set A are associated to different elements of set B, then the relation R from A to B is called a one-to-one relation. Another type, one-to-many relation. Here there are two sets. A has its element 1, 4, 9. B has its elements 1, minus 1, 2, minus 2, 3. Relation is from set A to set B. And its order pair are 1, 1, 1 minus 1, 4, 2, 4 minus 2, 9, 3. This relation is shown by an arrow diagram here. A 1, 4, 9 and B here 1, minus 1, 2, minus 2, 3. Relation is from set A to B. 1, 1 order pair representing it by an arrow here 1, 1, 1 minus 1 another order pair. The third one 4, 2, 4 minus 2 and the last one 9, 3. All the order pairs here is shown by an arrows here. Now in this figure 1 is associated to 1 and minus 1, 4 is associated to 2 and minus 2, 9 is associated to 3. Here at least one element of set A is associated with more than one element of B. Arrows here are 1 to many, 1 to 2, that is more than 1. So the relation is one-to-many relation. Let's define it. One-to-many relation. Let A and B be any two non-empty sets. The relation R from set A to set B is called a one-to-many relation if at least one element of A is associated with more than one element of B. The third type, many-to-one relation. Let's explain it with an example. Set A and set B are here. Set A has its element 1 minus 1, 2 minus 2, 3 minus 3, and B has its element 1, 4, 9. The relation is from set A to set B. And its order pair are 1, 1, minus 1, 1, 2, 4, minus 2, 4, 3, 9, and minus 3, 9. Now this relation is shown by an arrow diagram. The set A is here and set B is here. Relation is from set A to set B. Order pair 1 to 1, showing it by an arrow 1 to 1, that is 1 to 1, minus 1 to 1, 2, 4, minus 2, 4, 3, 9, and the last one, minus 3, 9. Here, 1 and minus 1 are associated to 1. The elements 2 and minus 2 of set A, they are associated to one element of a set B, that is 4. And 3 and minus 3 are associated to one element 9 of B. 2 and minus 2 are associated to 4, 3 and minus 3 are associated to 9. In this figure, more than one element of A is associated with an element of B. So arrows here are many to one. So this relation is called many to one relation. Let's define it. Many to one relation. Let A and B be any two non-empty sets. The relation R from set A to set B is called a many to one relation if more than one element of A is associated with an element of B. Now, the fourth type, identity relation. Set A is taken with its element A, B, C. Relation here is I, A to A. Relation is from set A to set A itself, and the elements of relation I are AA, BB, and CC. This relation is shown by an arrow diagram. Here, the set A and set B. The relation is from set A to set A itself, and the order pairs here represented by an arrow here AA, BB, C to C. A is associated to A itself, B is associated to B itself, and C is associated to C itself. So this one is called an identity relation. Here, every element of set is related to itself. The definition here, in an identity relation, every element of a set is related to itself only. Inverse relation. Let A and B be two sets. A has its element ABC and B has its element 1, 4, 9. Relation R is here. Its elements are A1, B4, C9. This relation is from set A to set B. Representing it in an arrow diagram, we have set A and B. The relation is from A to B. An arrow for A1 is here, A to 1, A1. Arrow from B to 4 for the order pair B4, and C9 is here. This is the arrow diagram for the relation R. Now, interchanging the components of each order pairs, we have a new relation R inverse, whose elements are 1a, 4b, 9c. We get this order pair by interchanging the components of each order pairs of R. So we have new relation, and the first components 1, 4, 9 are the elements of B, and the second components A, B, C are the elements of A. So here the new relation R inverse is from B to A. So showing it in an arrow diagram, we have B to A, that is relation R inverse. And for order pair 1A, we have arrow 1 to A, 4B, 9C. With this, let's define inverse relation. A new relation obtained by interchanging the first and second components of each order pairs of given relation R is known as inverse relation of R. It is denoted by R inverse. So, if R is relation from set A to set B, symbolically we can write it here. R is the set of order pairs A, B such that the first components from set A and the second component from set B. Then we have new relation R inverse is relation from set B to set A. We write here R inverse equals to B comma A, where B belongs to B and A belongs to set A. Now we are defining domain and range of a relation. Let A equals to 149 be a set and B equals to 1, 2, 3, 4, 5, 6 be another sets. Relation is from set A to set B. It has its elements 1, 1, 4, 2, 9, 3. Domain. Domain is defined here. The set of all the first components of the order pairs of relation R is called the domain of the relation. That is, set of all the first components. Here in this relation R, the first components are 1, 4, 9. Domain of R is set of first component, that is X of the order pair X comma Y, the first component X from the relation R. And while we list it, we get the domain as 1, 4, and 9. Now let's define range. The set of all the second components of the order pair of a relation is called the range of the relation. Here, the second component, set of all the second components, that is 1, 2, 3. Once again, we write the range here. Range of R is set of all the elements Y. That is second component of the order pair. Second component of XY from the set R. So the list of a range here, it is 1, 2, and 3, representing it in an arrow diagram. Here set A, set B, and R is the relation from set A to set B, and order pairs are 1, 1, 4, 2, and 9, 3. Here, the first set, the first components of the order pairs 1, 4, 9, it's a domain, and the second component of the order pair, that is 1, 2, 3, this one is the range of the relation. Let's take one more example. Here, relation is given in an order pair form, list form, A, M, B, N, C, P, and D, Q. When we collect all the first components from each order pair, it will form a new set which we call it as domain. That is, domain of R is set of all the first components, and when we collect all the second components, it will form a new set, range. So range has elements, all the second components from R. Okay, students, this much for today. Thank you.